myself. Okay, untuk exam, I plan to do a revision session with you guys, but the revision session is basically will be me going over questions yang korang tak faham nak buat during web assign. So untuk chapter 1 and chapter 2, kumpulkan soalan yang you think it's hard or you don't understand how to do it, and you let me know. We can make a list and we can try to address them in our revision. Sebab as I mentioned to you before, web assign ni dia akan test you guys on the things that we learn, and also we use ebook to derive the questions. So please make sure you know how to do the questions. If you copied your friends or just salin jalan kerja diorang, do not do that. Please make sure you understand, because nanti exam nak kena buat sendiri kan. Okay, so make sure you understand all the questions and how to do them, and if you don't know how to do it, then you can put it in the list of our revision questions later. Okay. Okay, so now we are going into chapter 3 actually. Okay, so chapter 3 is pretty interesting in my opinion. Okay, what's not interesting about physics? I think it's interesting. It's about you get to previously we talked about projectile motion, and I think that was cool because you get to know what is your landing speed, how far will your ball go if you throw a ball lah. Okay, so you actually can predict when you throw something, where will it fall and what's the landing speed. So that's pretty cool. For this chapter, you can actually know what are the forces acting on a certain object, and there's a bunch of forces and we'll learn how to determine them lah. Okay, so that is for chapter 3. Okay, so for chapter 3, it's called force and motion. Am I recording? Yes, it's called force and motion. So we are covering 5 topics here: inertia and momentum, Newton's law of motion, forces on objects, and then we have object in equilibrium and also object in linear motion. So equilibrium and linear motion are not the same. Equilibrium, I think you've heard of this word before. It means that the net force is equal to 0 or it's balanced. Okay, it's in equilibrium, it's not going to move, ataupun it's going to have a constant velocity. That is what it means. And then for object in linear motion, it can be accelerating. Typically, it's accelerating lah. Okay. All right, moving on. So we are learning about 3 Newton's law today. So after completing this chapter, this is our learning outcome. This is what you need to tackle for this chapter. Meaning to say, this is what we are going to question during the exam lah. So define inertia, mass and momentum, state Newton's law of motion, identify the forces acting on an object, and sketch its free body diagram. Okay, I have to admit this part is going to be tricky for you guys. Sama macam kita belajar about vector in chapter 1 when you had to resolve. I think that was tricky for you guys, but you guys got it. And then for chapter 2, we had to identify the vectors for a projectile motion and macam break down, resolve it into x and y as well, right? So that was the tricky part, and for this chapter, sketching its free body diagram would be the tricky part to this chapter. Okay, and of course, yang ni dah first one, this is your second one, this is your third one. So there's a lot of tricky parts to this one. This guy, and solve in equilibrium and solve in linear motion. Basically, it relates lah. All right. Okay, so inertia is the natural tendency of an object to remain at rest or continue its state of motion. So if it's not moving, it's going to not want to move. If it's moving, it's going to want continue moving at that specific velocity. Meaning to say, if I'm sleeping, I don't want to get up, right? So that is I am remaining at rest. I'm sleeping, so it's hard for me to get up. So that is like inertia, but that's not really inertia lah. That's a bad example. So what if I'm like just sitting? So the inertia is going to be greater because I'm going to resist getting up because sitting down is nicer. And if I'm just like walking at a certain pace, I don't want to go faster or I don't want to go slower, because it takes work. So kalau korang jogging lah kan, kalau korang jogging and you reach a certain speed, let's say, I don't know, 7 lah sebab korang muda kan, 7 kilometer per minute. So that's your pace. You will have a hard time trying to slow down, and you will have a hard time trying to make it faster, make yourself faster, because you are already at a certain velocity, and that is your comfortable velocity. Kalau korang jogging, korang akan tahu lah benda ni. Jogging, lepas tu you reach a certain speed and it gets hard to go slow or it gets hard to go faster. I'm not kidding you. It's really actually hard to go slow. So that is also because of inertia. Okay, so object at rest, you need a force to move a stationary object, and object in motion, you need a force to change an object's velocity. Okay, to make it faster or slower, or to stop its motion, and also to change its direction. You're moving to the right, it's hard to patah balik, or it's hard to go faster, or it's hard to go slower. Okay. Okay, again, you need a force to move a stationary object. It is more difficult to move a heavy object as compared to a lighter one. This is also related to inertia. The amount of force needed to overcome inertia depends on the amount of particles contained by the object. So this is measured by the mass lah, meaning to say mass affects inertia. So the heavier you are, or the heavier the object is, it's harder to change the direction, it's harder to change the speed, or it's hard to come to a complete stop. Okay. And then this is related to momentum juga lah. So this is, I don't know if this is new or not to you. So momentum is also related to inertia. For an object in motion, there is a natural tendency for an object to remain at constant velocity. It is more difficult to make such change for a heavy object as compared to a lighter one. I think at this point it's just repeating itself. It is more difficult to make such change for a fast moving object as compared to a slower one. Tadi kita cakap pasal heavy versus lighter. Now we're talking about faster compared to slower. So it's easier. Sorry, it's difficult for a fast moving. So fast moving ni kita boleh pair dengan heavy. So susah untuk kita gerakkan benda yang heavy. Sama macam susah nak stopkan benda yang laju. Okay, so heavy and fast is difficult. Light and slow is easier to change the direction or change its motion. So the quantity that measures the inertia, the tendency to remain at constant velocity or remain at rest, is the momentum of the object. So again, the quantity that measures the inertia. So inertia ni memanglah kita cakap, okay, lagi berat, lagi susah nak ni, lagi laju, lagi susah nak stop. But there's a way to quantify the inertia. So it's called momentum. So momentum is also the quantity that measures the inertia or the tendency to remain at constant velocity or remain at rest. And the equation is P equals to mv. We talked about how heavy akan jadi susah, fast akan jadi susah. So when this guy is faster, it goes up, right? So momentum also goes up. When your mass goes up, it is heavier, your momentum also goes up. Meaning to say, if you have a greater momentum, it's harder for you to stop, or it's harder for you to change motion. Okay, so it's related to this equation, P equals to mv. P is a vector, momentum is a vector because it is mass times with velocity, and mass is a scalar quantity. When you times it with a vector quantity, it is a vector quantity. This is not dot product or cross product, it's just regular multiplication. When you have regular multiplication, it follows scalar times vector, jadi vector. Okay. So mass is in kg and V is in meter per second. This is your SI unit lah, macam biasa. Meter, this is kilogram. Jangan pakai gram pula meter per second, okay? So the heavier your mass is, the greater your momentum. The faster your velocity, the greater your momentum. So a greater momentum causes you to have a greater inertia, and lagi susah nak berhenti atau lagi susah nak tukar direction, atau lagi susah nak lagi laju atau lagi slow. Okay. So now we go into Newton's first law, which is actually inertia. So Newton's first law is an object will remain at rest or moves with a constant velocity unless acted on by a force. So this is actually Newton's law, Newton's first law, also known as the law of inertia. Okay, so this is the definition. An object will remain at rest or moves with a constant velocity unless acted on by a force. That is your law of inertia or Newton's first law. This can come out. Can you define Newton's first law? So you have to like memorize the definition. All right. So what is the relationship between force with momentum, right? Previously, we talked about how a greater momentum will cause a greater inertia, and that causes the tendency of an object to remain at rest or move with a constant velocity. So in here, all moving objects has momentum. Okay, P equals to mv. Kalau dia tak bergerak, V equals to 0, then it doesn't have momentum, right? We need force to change its velocity. Now, when we talk about change in velocity, over the change in time, we are talking about acceleration. If you guys still remember from chapter 2. So we need force to change its velocity. How is this related to change in velocity? Because when you have acceleration, you will have F equals to ma, assuming you have mass lah. Ada ke benda yang tak ada mass kan? So when you have a change in velocity over the change in time, why is the change in time involved here? Because we are always changing in time. As I'm talking here, I have a change in time, you have a change in time. Our change in time is the same. So any quantity sebenarnya, when we're talking about any change in quantity, there is a change in time because time keeps on moving. Kita tak boleh nak berhentikan time, right? Unless we are like taking a photo, then that time is captured. But when we are talking about something that is occurring, the time is always moving. So when we talk about change in velocity, we have to include the change in time because time is always moving linear. Okay, we're not going to talk about parallel worlds or like time kat tempat lain ke apa benda. I don't know those theories. Korang boleh baca sendiri. So the change in velocity over the change in time gives us acceleration. Force is equal to ma. Therefore, you will have force when you have acceleration. When your acceleration equals to 0, that means, mana pergi slide ni? That means your change in V is also equal to 0. Then there's no change in velocity. Okay, no change in velocity means A equals to 0. There's no force. So for force to happen, you need to have a change in velocity. First, because you need to make it slower or faster. That's like obvious, right? And then when you change the momentum, you will also have that force because you are changing velocity. So we need a greater force for a quick change rather than a slow change. So of course, I think this is like common sense. If you're moving, if you are like impacted by a lorry versus a car. So lorry ni dia tolak by like 100 Newton versus a bicycle lah, kesian korang. So bicycle is like bila dia terlanggar korang, it gives you like a force of 5. Of course, this guy, the lorry guy, will immediately stop you in your track. Hopefully this does not happen. This is not a prayer, I mean. So if you get hit by a bicycle, maybe tergolek-golek dulu ke baru stop. So it takes a while for you to change your velocity to a complete stop. Okay? So ada perbezaan when you apply a bigger force and versus a smaller force. That was a bad example. I don't wish that upon anyone. Okay, so the general form of Newton's second law. Now we're going to Newton's second law. So what was the first one again? The first Newton's law states that it's actually the law of inertia, which is the tendency of an object to remain at rest or move at a constant velocity unless acted on by a force. So and we talked about the force, right? We have to have a change in velocity to have the force. Now, we're talking about the rate of change of momentum. Tadi kita cakap pasal change in velocity. Now we're talking about the change in momentum of an object. is directly proportional to the force acting on it. Nampak macam lebih kurang kan dengan Newton's first law. Sebenarnya dia kesinambungan. So you have the first law talking about inertia. Second law dia explain pasal inertia tu tapi in other equations. And then the third law sama je, dia kesinambungan semua ni. So F is proportional to the change in momentum over the change in time. What is momentum again? P equals to mv. P is a vector, velocity is a vector. Okay, when you have a change in P, you don't know where the change comes from. Is it from the mass or is it from the velocity for you to get the change in P? So nanti kita akan bincang pasal ni. So again, force is proportional to the change in momentum over the change in time. Okay, so as I mentioned to you before, if we have a delta on your left side, right? If you have a delta on your left side, you have to have a delta on your right side. Tak boleh delta P equals to mv. This is like totally wrong. Your delta did not come out of thin air. Kalau dia datang kat sebelah kiri, dia kena ada kat sebelah kanan supaya dia boleh cancel out sebenarnya. So it needs to be balanced. You can't have the delta on one side only. So when we're talking about change in momentum, that change has to come from something. And that change can be from the mass or from the velocity. So force equals to dp dt. I think I told you before, the d in differentiation actually means change. It actually means delta. But for differentiation, it is a really super small delta. Therefore, they call it the word d. Differentiation, dia very small dia punya change tu. But it basically is delta, but delta yang super small. Okay, so the change in momentum over the change in time, super small, right, is also equal to the change in mv over time, over the change in time. So when you expand this equation, right, it becomes m dv dt plus v dm dt, because you have instances where the velocity changes, but your mass is constant. And you have instances where you have the change in m, but your velocity is constant. Okay, so bila dia expand, dia akan jadi macam ni. So d dt of mv is m dv dt plus v dm dt. This is when your mass is constant, and this is when you have a change in velocity. This is when your velocity is constant, and this is when you have a change in mass. But our mass does not actually change, right? If I'm like 50 kg, I'm always 50 kg unless I eat a lot and then I gain weight, then that's a different thing. But my mass, when I'm like talking, moving, something, doing activities, my mass is constant. It doesn't ever change. It doesn't change in like a day lah, basically. So if my m is constant, then the change in m is equal to 0. So the change in m is equal to 0. So if we look at this equation, when your change in m is equal to 0, right, then this guy becomes a 0. And the 0 times with v becomes 0. So you're left with m dv dt, which is equal to ma. So that is how you get your F equals to ma equation. Okay, because we assume that everyone has a constant mass. It doesn't change. Unless like tengah jalan ke tiba-tiba naik 1 kg, then that means your mass is like constantly changing. So you can't use this equation. F equals to ma does not apply to you. But if your mass is constant, then F equals to ma applies to you. Okay, mana ada orang yang tak constant mass kan? Okay, so let's be real here. All right, so Newton's second law of equation for constant mass m is F equals to ma. Acceleration is a vector, mass is a scalar. Therefore, force is a vector. No questions? Okay. No questions? All right. So the SI unit of force is called Newton. No, it's not called. It is Newton, ataupun capital N, which is the force on 1 kilogram of mass to accelerate at 1 meter per second squared. So if you're like wondering where did this come from, it came from the equation. So M is 1 kg Acceleration is 1 meter per second squared. It is to accelerate 1 kilogram of mass at 1 meter per second squared. Okay, that is your Newton. Newton is defined by accelerating the force to accelerate 1 kilogram of mass by 1 meter per second squared. Okay, if you're not sure where this comes from, it comes from the equation, just derive it. Or not, just memorize F equals to ma. Okay, if there is a change in mass, like I said to you before, we assume that we have the constant mass. What if ada orang yang boleh tukar-tukar mass ni? Maybe not orang lah, maybe like an artificial being, right? Macam kita buat in vitro, tak apalah. I won't talk about biology. I'm not good at it. So assuming there is a creation that is able to change in mass, right? So this equation F equals to ma is not legit anymore. So you have to use like the actual one, F equals to m dv dt, or basically A plus v dm dt, or the change in mass over the change in time. So it becomes F equals to ma plus v dm dt. Okay. So this is Newton's second law if m is not constant. But for our syllabus, we assume everything has a constant mass. So F equals to ma je lah. Okay, so Newton's third law. Okay, so let me do a recap first lah. Okay, I think I talked a lot. So kita buat recap dulu. For everyone is becoming like lost ke apa ke. Okay, so we talked about Newton's first law. Okay, can anyone tell me what that was? Newton's second. Okay, anyone summarize you. Like what did you get from the Newton's first law?
Inertia.
Okay, it's the law of inertia. What else? What else? What happens if we have a greater mass? Is the inertia greater or smaller?
Greater.
Greater inertia. What else? Apa yang menyebabkan inertia besar?
Velocity.
Velocity, right? So you have, if you are going faster, your inertia is also bigger. And this relates to P equals to mv. So a greater inertia also means a greater momentum. Momentum is the way to quantify inertia. So kalau dia tanya, macam mana nak kira inertia? Pakai momentum lah. The word is momentum. Don't use inertia. So law of inertia states that an object has the natural tendency to remain at rest or move at a constant velocity unless acted by a force. Unless acted by a force. Okay, has the natural tendency. Saya tulis kat depan ni. Natural tendency. What is the natural tendency about? It is to remain at rest or remain at constant velocity. Okay, so this is your Newton's first law. Okay, and then Newton's second law tells us that F is proportional to the change in momentum over the change in time. This is equal to F equals to m dv dt plus v dm dt. If mass is constant, then F equals to ma. Okay, so that is your Newton's second law. Okay, now we go into Newton's third law. If object 1 and object 2 interact. Okay, so what is object 1 and object 2? The force exerted by object 1 on object 2 is equal in magnitude but opposite in direction. So our first object is actually this, let's call it a brick. So that is your object number 1. And your major is object number 2. So the brick is exerting force on the major. How do you know it's exerting force, right? Okay, so basically everything in this world has weight, unless it doesn't, but everything has weight, right? So when we put something on a table, it is exerting its own weight on the table. Kalau tak percaya, boleh pegang sendiri and you will feel that it's heavy. There is some force pushing down on your hand when you put an object on it. So there is actually a force. So the force exerted by this brake, we call it as F12 because the force of object 1 exerted on object 2. And object 2 does not like this. So he wants to counter ataupun it wants to counter balik lah. Kenapa kau boleh tolak aku kan? Aku pun nak tolak kau juga. So F21, we have an equal but opposite force. Equal but opposite force. And we call it as F21, meaning to say the force from object 2 exerted on object 1. So this is the force from the table on the brake. And this is the force of brake on table. They are equal and opposite. So this is Newton's third law. So if object 1 and object 2 interact ataupun bersentuhan je, the force exerted by object 1 on object 2 is equal in magnitude but opposite in direction to the force exerted by object 2 on object 1. We can write this equation F12 is equal to F21. Okay, so this negative sign means opposite direction lah, but the magnitude is equal. It is equivalent to saying a single isolated force cannot exist. So whenever you have a force acting, there is always another force acting back on it. So that is what this Newton's third law is saying. Okay. Okay, so there are several types of forces that we are going to learn in this chapter. The first one is called external, bukanlah, the category. So the first category is called external force. So for example, we have gravitational force, magnetic force, push-pull, kita tengok example nanti. Then we also have internal forces such as nuclear force, weak force, vibration of atoms. So yang ni kita takkan cover, but it can, the question can ask you, what are some examples of internal forces? So vibration of atoms, weak forces between molecules, something like that, or nuclear force is the internal forces. Benda yang kat dalam lah, benda yang dalam objek kita tak nampak. Jadi force memang tak nampak pun, but memang benda yang inside, we can't really draw the force outside. It's going to be inside the object. So that is internal force. Okay, so if I have an object, right? So if I'm pushing this box, so this is something that I can draw outside of the object. I'm pushing it by 10 Newton. What else? Gravity is acting downwards. Sepatutnya. That is G. So this is something that I can draw outside of the box. And if this box is made out of iron, I put a magnet next to it. So it's going to be attracted to this magnet. This is also something that is happening outside of the object. So these are external forces. So things that happen inside the object, for example, the vibration of atoms inside, right? It goes inside, and there is like weak molecular interaction between the atoms that is also inside. So forces that is inside the object, we call it as internal. And we won't go into detail on that. So you just have to, if you want to remember these examples, these are great ones. But that's about it, okay? So external forces, kita akan go into deeper, we are going into more detail on external forces. External forces ada contact and non-contact. Okay, we have external force, dibahagikan kepada dua, which is contact and non-contact. Contact tu bersentuhan lah, bersentuhan or tak bersentuh. So for example, we have this contact force, pulling. Okay, so pulling force is a contact force. Then we have, this is also pulling. Pulling force is a contact force. When this auntie is tarik anak dia tarik lah kan, dia nak tarik the trolley. And then this is this is push force. This is pushing force or push force. When you are trying to kick a ball, you are pushing your legs. Doesn't seem like you're pushing, but it's actually called pushing. Mana ada orang tarik kaki nak sepak kan? So you are actually pushing. So, and then we have field forces, which is a non-contact force. So this is gravitational force. Gravitational force. This is apa? Moon and Earth, contoh, or anything, or any two planets lah. You have that gravitational pull. So it's a type of force that you don't have to touch for it to happen. Basically happens lah. And then we have the electrostatic force. The electrostatic force between two charged particles. Two charged particles. So particle yang negatively charged and particle yang positively charged. They will be attracted to each other without even in contact. And then we have magnetic force. Okay, so if this object is made out of iron, it will be attracted to a magnet. It doesn't have to be in contact for the pull to happen. The object feels the pull. This particle feels the pull or the push. The moon feels the pull or the push from Earth. Okay. Okay, forces on an object that we are going to tackle in this chapter is gravitational force, weight of the object, not between planets yet. Planet tu nanti chapter kemudian. So gravitational force yang weight lah, weight yang biasa tu. And then we have the normal reaction force, which is called N or R. This guy is called G, or you can write it as W. Boleh dua-dua, boleh. Sorry, this is mg. Because weight is always mass times gravity, or W. And then we have N or R for normal reaction force. Boleh dua-dua, tak kisah, dua-dua sama. Then we have frictional force, yang ni tak boleh ada dua, ni satu je. Rupa dia small f. Tension on string is called capital T. And then other direct contact force, push or pull, you just label it as it is. Contohnya, if you are like kicking a ball or pushing a ball by 10 Newton, you just label it as 10 Newton, or you can label this as F1. Boleh. F1 ke Fx ke. Don't use Fx lah. F1 ke F2 ke F3 ke. Okay. And when you want to resolve, then baru pakai Fx, Fy. Haha, saya dah bagi hint dah. Memang ada resolve kan kat sini. Kena resolve forces. So again, we're using chapter 1 and chapter 2 punya knowledge on chapter 3. So semua ni berkait-kait. Okay. Okay, ni label as F sahaja. F1, F2, or just the magnitude. 10 Newton, 20 Newton. Okay, boleh terus label. Yang lain kena ingat dia punya notation. Mg or W, capital W, N or capital R, small f for friction, and tension for is capital T. Okay, gravitational force is a field force. We know this. It is due to the attractive force between any two objects. So Newton's law of gravitational force states that F equals to G gravitational constant. Oh, sorry, it's universal gravitational constant. You have that capital M, small m over R. R is the radius between the two planets. Capital M is mass 1. Small m is mass 2. Oh, sorry, terbalik. Boleh je mana-mana, tak kisah. And then G is just a constant. Nanti the value will be given. Do you have to memorize this equation yet? No, not at this point. For chapter 3, you don't have to memorize this. This is for chapter 5 nanti. Chapter 6 nanti. Okay, I'm just introducing this equation to you. So attraction between planets is defined from Newton's law of gravitational force. And this is the equation for an object. Tak payah masuklah ini. Nanti kita akan belajar kemudian. Okay, so for an object near Earth, we just say, from this equation juga, we just say the acceleration is G equals to 9.81. This is specifically for objects on Earth, or for us on Earth. Specifically, our acceleration is G equals to 9.81. Kenapa dia bagi tahu macam ni? Sebab bila you are somewhere else, meaning to say you are at other planets, the gravitational acceleration or the acceleration on other planets is different. For example, the acceleration on Moon is different. The acceleration on Jupiter is different. And if you are flying like way above Earth, gravitational acceleration is different on you because you have a certain height. So when does G equals to 9.81 applies? Only when you are on Earth. It only applies when you are on Earth actually. So this, how did we determine 9.81? It is from this equation. Nanti kita akan belajar in chapter 6 nanti. So I'm just trying to tell you that the G equals to 9.81 only applies when you are on Earth. If you are Superman or whatever yang melayang-layang kat atas tu, the G does not apply to you. You have a different G. You have a different acceleration. And if you are on a different planet, you have a different acceleration. You want to become lighter, you want to become heavier, go to other planets. Boleh. You will have a different weight. Okay, so the force of gravity is commonly known as the weight of an object. W equals to mg. You can label W or you can label it as mg. Dua-dua boleh, tak salah. Oh, sorry. So when we are labeling an object with a mass, we go downwards lah. I think you know this by now. Downward means the direction is going downwards. Downward arrow means it's going downward. Okay. And then we have the normal reaction force. Normal ataupun reaction force always exists when two objects are in contact. So you have this TV, it's in contact with the table. And I told you the TV will always apply some force because there is some weight. But so here the weight is Fg going down, and there is a reaction force because of this contact. Okay. Okay, let me rephrase that. First of all, we have this TV, right? Okay, sekarang ni jangan fikir pasal Newton's third law. Jangan fikir pasal Newton's third law. So Newton's, sorry, cakap pasal Newton's third law pula. So we have this F equals to G, F equals to G, or sorry, F equals to mg, which is the weight, or F equals to W. And then we have the reaction force when it is in contact. We have the reaction force when it is in contact. Other instances, kereta atas jalan, it is in contact with the road. There is a reaction force. Okay, there is a reaction force. Okay, so how does this relate back to Newton's third law? Okay, so kalau tengok kat sini, kita punya weight adalah ke bawah. So if this object is not moving, then R should be equal to mg. So this is Newton's third law cakap kalau ada exerted ke bawah, ke atas pun ada kan. So this is actually related to Newton's third law lah. Tapi if I say that the reaction force exists on its own when we have the Fg, salah tak boleh cakap. Tak boleh cakap kalau ada Fg sentiasa ada R, tak boleh. You can't say that. Kalau ada gravitational force, you will always have R. That is incorrect. The reason R exists is because you have that contact. If you are floating in air, you have, sorry lah, you patutnya kat sini you have that Fg, but you don't have that R. You don't have that R. So where is your Newton's third law? Yang tu chapter lain, yang tu lagi detail lah. So sekarang ni kita cakap pasal contact kan. So when you have a TV that is in contact with an object, there is a reaction force. If the TV is floating, there is a gravitational force, but there is not necessarily reaction force. Walaupun kita nak relate back to Newton's third law, tapi tak boleh kalau dia tak ada contact. Kat sini tu tak boleh lah. Ada cara lain dia untuk determine the third law tu, tapi yang tu masuk subtopic lain. Okay. So for now, anything that is in contact will have a reaction force. And the reaction force will be balanced out by something that is going in the opposite direction. Okay, so now let's look at the car now. Okay, I told you reaction force, dia akan ada kalau ada contact, and dia akan balance out with a force that is in the opposite direction, right? Where is the opposite direction in this case for this car? So we have the reaction force. Reaction force ni selalunya akan 90 degrees to the surface. Kita tengok tadi TV tadi 90 degrees to the surface. Always perpendicular. Sebab tu nama dia normal lah. Normal is 90 degrees. So where is this guy punya opposite force, right? To balance it out. Ada. Saya tunjuk saya intro dulu. So your mass goes down here. Sorry, your gravitational force, Fg, is down here. It's not actually in the same line as the normal reaction force. So you have to resolve it. Yay, resolve. So angle, kalau ini theta, this will become F equals to Fg. Let's just say this is mg lah. This will be mg, your gravitational force. So this would become mg cosine theta. Yay, kita resolve. Okay, so this is where the reaction force gets balanced. Sebab yang ni kita punya gravity force ke bawah macam ni. Remember, gravity always goes downwards. Walaupun road tu condong ke apa ke, your gravity always goes downwards. Dia tak ada condong-condong. So if you want it to become condong, you have to resolve it. Kalau kat sini, example TV tadi, your your reaction force is balanced out by the gravity force, weight ataupun weight. Okay, so I realize this is going to confuse some people. Kalau soalan boleh tanya. Okay, and again, this is a box on a table. The mg is balanced out by the reaction force. It is in contact. That is the most important thing. If you have contact, baru ada reaction force. This is your box. The reaction force is 90 degrees tadi. This is your box, you're pushing it. The contact is here. Therefore, your reaction force is 90 degrees to the surface. It is balanced out by the force exerted by your hands. Okay. And then if you have an object on a plane, so if you have an object on this thing, the contact is here, the angle should be 90 degrees. That is your reaction force. Tak kisah dia bersambung dengan apa pun, asalkan ada contact, you will have that reaction force. Does this object have reaction force or not? Going upwards, does it have reaction force?
No.
No, it's not in contact with anything, right? Kalau nak ada reaction force juga, letaklah table bawah ni. Then you will have that reaction force. But since it's floating, there's no reaction force like I mentioned earlier. Okay, but we have other forces in this guy. Nanti saya akan masuk into. Okay, so and then we go into force of friction. When an object is in motion or tends to move, maksudnya dia baru nak gerak macam korang baru nak gerak kan, macam tu kan. So there is a force of friction happening on a surface or through a viscous medium. There will be a resistance on the motion. You are moving, so there will be resistance on the other way. Your friction always opposes motion ataupun always opposes the tendency of motion. In this case, this is you, this is not me, this is you. You are moving to the right. The friction will be to the left. It always opposes motion or the tendency of motion. Let's say you are not moving, but you are ready to move to the right. Friction will happen on the opposite direction as well. Masa tendency of moving tu. Maksudnya baru nak gerak, dah ada friction dah. Friction dah start dah. Okay, this is due to the interaction between the object and its environment. Okay, what environment is that? Lantai lah, lantai kasar kan. Bila ada kekasaran, there is geseran. I think geseran is friction in English. So this resistance is called friction. Okay, ada resistance, ada the opposing of the motion. Resistance, okay. So direction of friction is always opposite to the direction of motion of the object. Generally, generally it is independent of the area of contact. Dia tak kisah lagi besar bongkah tu ke ataupun lagi kecil ke, tak kisah. It doesn't care. And the speed of object also does not affect the friction force. The force of friction is dependent on the normal force acting between the surface. Now, immediately when you talk about friction that is dependent on the normal force, you know that friction has to happen when you have contact. When you don't have contact, there's no friction. Sebab dia dependent on normal force. Normal force only happens when you have contact. So kita hanya akan ada geseran ataupun friction when we are in contact with something. When I'm touching this pen, there is actually friction for me to actually able to hold it. If there's no resistance between my hand and the pen, then it will just slip out of my hand. Licin kan? Kalau benda ni macam jelly ke, jatuh. So there's no friction. It's slipping out of my hand. When I'm touching it, it is actually able to stay in my hand because of friction ataupun resistance to the motion. Pen ni dia nak bergerak ke bawah because of gravitational force. There is a resistance of motion from friction. So everything has some physics to it, right? So pegang pen pun ada. So there's the friction force. Okay, so friction force is equal to mu times normal. So mu is called the coefficient of friction. Coefficient of friction. Okay, everyone, please pay attention. Mu is called coefficient of friction. Nanti kan, saya rasa lepas ni kelas ni ada orang tanya, Doktor, mu tu apa? Doktor, simbol ni maksud apa? Dia saya ketuk. Sebab saya dah repeat 3 kali kat sini. So friction is equal to mu times R. What is mu? Mu is the coefficient of friction. And the value depends on the surfaces in contact. Okay, so it depends. Value dia depends. So kalau kita geserkan wood with wood, okay, so the coefficient of static friction is 0.4 and the coefficient of kinetic friction is 0.2. So sekarang kita ada 2 types of coefficient. The first one being static and the second one being kinetic. Okay, nanti kita akan masuk. Okay, so ada perbezaan lah. So kalau kita tengok kat sini, static friction punya coefficient lagi tinggi daripada kinetic. Static ni bermaksud berhenti. Kinetic ni bermaksud bergerak. So lagi tinggi coefficient of static friction berbanding kinetic friction. Bermaksud kat sini, when you are at rest, the friction is actually greater than when you are moving. It's because small f equals to mu r. So kalau mu kita besar, kita punya friction pun besar. So if your values of static friction is higher, it says here that kalau tengah stop, lagi susah nak bergerak because of the higher friction. When you are moving, the friction becomes smaller. Okay, hari ni cerita je, tak ada exercise pun. So forces of friction ada 2, static friction and kinetic friction. Static friction acts to prevent object from moving and kinetic friction opposes motion by slowing it down. So bila tengah gerak, dia nak bagi kita perlahan. Kalau static friction, kalau kita belum bergerak, dia tak nak kita gerak. Dia prevent us from moving. Okay, so I think I'm going to stop here. Kita sambung next class, okay? So any questions so far? Let me just do a little recap first before we totally end class. So we talked about several forces. If I have an object that is moving to the right, so I have gravity acting on it, mg, and then if it is moving to the right, I will have friction force opposing the motion. So that is your F. If it is in contact with lantai, it will have R. Okay, so how is it moving to the right? I am applying some force, so I just label it as 10 Newton. Okay, so that's it. Have a great rest of the day. Take care. Bye, guys.
Thank you, Doctor.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Thank you, Doctor. Thank you, Doctor.
Thank
Thank
you,
you,
Doctor.
Doctor, can I ask you regarding on lab 2
Yes.
for projectile motion?
Uh-huh.
I want to ask you the derived equation for vertical speed is Vy is equal to square root 2gh. So is it vertical speed for all the trials will be the same?
Will the vertical speed for all the stripes will be the same? Fine, I don't know. So, jangan saya tengok buku balik, saya ingat. Can
Okay,
can
okay.
we talk on WhatsApp
Okay.
for the class kan? Okay, bye.
Okay, bye. Thank you.
Alright, bye bye.